Okay, very good morning. This is tutorial 2. In our kuliah, in our lecture on Monday, we stop here. Okay, this is where we stop, and let us continue from here. This is we are going to continue from exercise 1 here. Any problem in my voice or you cannot see the screen, please somebody have to let me know, yeah, because you have to open your mic and talk to me. All right. Exercise 1. Calculate the marginal probability. So marginal, I told you last time, we go by row or column. Okay, so here if I want to find A1 plus 0.4 plus 0.2, so I get 0.6. A2 0.3, 0.4. B1 plus this row here, 0.7. And this row 0.2 0.1, you get 0.3. So that's how you find marginal probability. Next is determine the conditional probability. Okay, A1 intersect B1 is here, 0.4, joint probability here, and then probability of B1 just now we found, that is 0.7. A2 intersect B1, A2 intersect B1 is A2 B1 is here, 0.3, B1 just now 0.7, you get 0.43. A1 B2 0.2, and probability of B2 is 0.3, you will get 0.7. and B2 A1 is still 0.2, but A1 is 0.6. You will get 0.33. So that is the conditional probability here. These events are independent, so basically they will ask you two events are independent. I just put here these events are independent because we have calculated all the probability. So for example, if I want to know if I want to know A1 and B1 are independent or not. Okay, I want to know A1 and B1 are they independent. So let us see. A1 B1 is equal to 0.57, and then A1 is 0.6. The condition is for me to say that A1 and B1 are independent. Okay, for me to declare A1 and B1 are independent, this probability must equal to this probability. Are they equal? No, isn't it? So not equal, so not independent. Remember the rules, hope you guys still remember this one. This one, two events A and B are said independent if the probability is equal. If not equal, not independent. So A1 and B1 are not independent. Okay, you can do this for the rest also. You can, this one I do A1 and B1. Okay, so you can also check for A1 and B2. Okay, the same method you can try, same method, and then A2 and B1 and A2 and B2, same thing you can try. The answer is all are not independent because we have different the value of probability is different here. I just did one here, the rest there are three more cases, you can try yourself. Okay, now compute A1 or B1. So I can write this as A union B1s, because last time I teach you or last class we saw that or can be written as union or plus. So A1 B1 formula is A plus B. This formula is here. You can see this one. A1 plus B1 A1 intersect B1. Okay, N is intersect, O is union. Okay, that's the notation. So we have found PA1 just now. A1 is 0.6. And B1 is 0.7. Intersection will give you, there's no intersection. For intersection we can find from the table here. A1 B1, that is 0.4. If you do this, you will get 0.9. A1 is 0.6, B2 is 0.3, A1 B2, A1 B2 is here 0.2. If you do this, you get 0.7. A1 is 0.6, A2 is 0.4, and A1 intersect A2. Okay, there's no intersection here. Basically, the variable or the character on the same category, they won't intersect. Here A1 and A2 no intersection, B1, B2 no intersection. Only different category have intersection, A and B. So this one no intersection, 0. The answer is 1 here. Exercise 2 is the same. You can try. I'll share the answer. For exercise 3, I will do exercise 3 here. Department store analyze its most recent sales and determine the relationship between the way the customer paid for the item and the price category for the item. The joint probability in the following table were calculated. Okay. What proportion of the purchase was paid by the debit card? So A. Probability of debit card. Probability of debit card, you plus all this 0.04, and you will get 0.36. Find the probability that a credit card purchase was more than 100. So given it is a credit card, find the probability was more than 100. More than 100 intersect with credit, divide by credit. More than 100 and intersect with credit. This one, and credit card, you plus all, you will get 47, 0.47. You press this in the calculator, you get 0.49. Determine the proportion of the purchase, okay, made by credit card or debit card. credit card or debit card. Use the formula. Probability of credit card is 0.47, this one, plus probability of debit card is this one, minus credit intersect with debit, this one intersect with this one. So same category, there's no intersection, so this is 0 here. So answer is 0.83. Alright, so number 2 and 4 you try to do later. I'll try to share the answer. For number 5 you can do, but I don't recommend. I mean, you can try number 5 because I just simply give, because the wording is very complicated. You can skip number 5 if you want. You can do enough, sufficient for you to do until the exercise 4. Okay, so far what we have done, let me recall. So far what we have done in the class and until now, when I say in the class, it's a lecture, Monday class. Recall, we learn basic probability, basic terms. We learn joint probability. Okay, joint probability is the one with the word and in the notation intersection and the multiplication notation, all are same. Okay, it looks like A intersect B, something like this. Okay, and then marginal probability. Marginal probability we get by adding row or column. Okay, this one PA, the notation is PA or PB. And I think last one we learn union. Or and plus. Notation is like this, and there's a formula for this one. This will be the formula. So far this is what we learned. Okay, just to recall all the things. So next we go for tree diagram. Okay, next we are going for tree diagram. Before we go through this example, let me give my own example here. Before I go through this example for tree diagram, let us look at this example. So for tree diagram, okay, we will draw some branches. We call this a branch, like this. This is known as branch. This point is known as node. Okay. So let's say in one day there will there will be rain or no rain. No rain notation, I put R, there's a line. Okay, I call this as bar. The probability of raining is, let's say, 0.7. Okay, and the probability of not raining is 0.3. The branches coming out from the same node, okay, for the branches coming out from the same node, if you plus the probability must be 1. Remember that. Okay, so if I say this is 0.7, automatically you should know this is 0.3. Now, yes, raining, this is raining, not raining. Another branch from here, umbrella, no umbrella. This is umbrella, this is no umbrella. Umbrella, no umbrella. If it is raining, the probability of you bringing umbrella is 0.8. If it is raining, the probability of you not bring umbrella, here 8 already, so here should be 0.2, because coming from same node, if you plus this should be 1. Okay, this one no raining, bringing umbrella is 0.6, and here should be 0.4. All right, this is, let's say, with this information, okay, with this information, let us go into more detail. So what does this number tells you? This number is a probability of what? Probability of R. Okay, probability of R. What does this number tells you? Probability of not raining. What does this number tells you? This number tells you, it's not like probability of U, no, this one, yes, first branch, yes. The second branch is not directly for you. That's the notation for 0.8 is given it is raining, the probability of U is 0.8. That's what the notation for 0.8. Same goes for 0.2. Given it is raining, what is the probability of not bringing umbrella? This one, given it is not raining, U, given it is not raining, U not bringing umbrella. So be careful. Okay, this one first is easy notation, R and R, not R. But the second notation is a conditional probability. Okay, now let's see. If you let's see what is the probability of raining and you bring umbrella. raining, you bring umbrella, you go by branch. Okay, if you go by branch, you multiply. Okay, so raining and umbrella, raining and umbrella. So what is this notation? R and U. N means this one, isn't it? I told you just now. So this is how you remember. Okay, so this notation is single notation R. 0.8 is conditional, and if you multiply by branch, go by branch, you will get the joint probability. How about here? You go by branch. You go by branch, what do you get? 0.7, 0.2, you get 0.4. Okay, this is the notation. So the main idea is whenever you draw a tree diagram, you should know all this notation. Okay. So we know PR, we know PR bar. This is conditional. All these are conditional probability. Okay, you can know the second branch is for going for conditional probability, and if you multiply by the branch, okay, multiply by the branch, you will get joint probability. But here let me ask you how to find. We know what is PR. PR is 0.7. This one. We know what is PR bar. This is 0.3. Now how about PU, probability of bringing umbrella? Because here no, isn't it? Here there's no notation of only for umbrella. So what you do, you take the U. Okay, you want probability of umbrella U, isn't it? And then go for U plus both of them. If you plus, you will get 0.74. Same goes this one. You go for U 0.26. That's the thing. Now to check, you if you plus all this number, you should get 1. Total probability is 1, so you plus all this, you should get 1. So this is the example for tree diagram. Hope you guys understand how to find the single probability, conditional probability and joint probability. Now we are going for one example here. You are off to soccer and love being goalkeeper, but that depends on the coach today. Coach Sam is, if with Coach Sam, the probability of you become a goalkeeper is 0.5. With Coach Alex, the probability of you become goalkeeper is 0.3. Sam is coach more often, about 6 out of 10 games. What is the probability you will become a goalkeeper? So based on this information, there is coaches, Coach Sam and Alex, and you become goalkeeper. Goalkeeper, not a goalkeeper. Goalkeeper, not a goalkeeper. Okay. What is the probability of Sam becoming coach? Can see here, Sam is coach more often, 6 out of 10 games. So 6 out of 10 games. So this is 0.6. That is the probability right here. But here, if here 0.6, how much is here? 0.4. Okay. With Sam coach, the probability of you become a goalkeeper is 0.5. If Alex is coach, the probability of become goalkeeper is 0.3. If you plus this, if here 0.5, here is 0.5. Here 0.3, here is 0.7. What is the probability you will become a goalkeeper? So we want, remember, goalkeeper, they want this probability of goalkeeper. So probability of S is this one, probability of A is this one. If I want probability of G is here, so take this one and this one. 0.6 multiply 0.5, 0.4 multiply 0.3. This branch, and also this branch. If you do this, here you will get 0.30, here you will get 0.12, you plus, you get 0.42. That is the answer here. Now next example 2. A graduate statistic course has 7 male and 3 female. A professor want to select 2 students at random to help her conduct a research project. What is the probability that two student chosen is female? So they are male and female. Okay, male, female. The probability of choosing a male as a first student, this is first student, first student, this is second student, male, female, can be male, female. Probability of choosing a male is now is 7 out of 10. So you get 7 out of 10. This one is 3 out of female. Now for male, they choose two student, so one student is came out already, chosen already, so left is 9. Okay, you choose male, one student came out already. For example, just now you have 7 male, 3 female, isn't it? Now for the first student, let's say you choose male. When you choose male, one male came out already, left is 6 male, isn't it? Okay, left is 6 male. So total is 9 here, that's why I put a 9 here. How many males are more? 6. Female, 3. Now let's say you choose first student as female, so this one left reduced to 2 female. How many male are there? Still 7. How many female are there? Reduced to 1, 2. So that's how you see the tree diagram for this example. What is the probability that the two students chosen are female? So female and female, female and female. Two students are female, you go by this branch. What you have to do? Multiply. You multiply, you get 1 over 15. Probability of both female is 1 over 15. Now next example, example 3 here. The professor who teaches the course is suffering from the flu and he will be unavailable for the 2 classes. 2 classes, the professor here unavailable. It's almost the same question. Okay, just change it a bit. So now there's a replacement. Professor replacement will teach the next 2 classes. So 2 classes will be teach another replacement teacher. Okay, the replacement teacher style is to select one student at random and pick up to answer question during that class. Okay, which means this is 2 class. This is 2 person at one class. This one is 2 person at one class. Okay, so one student came out, you have to reduce by 1. Now this one is he going to ask one student only. Okay, this is the first class. The replacement going to teach 2 classes. This is first class, male, female. Second class, male, female. One student at random. So he in the first class, the teacher will choose any one of them. So the probability of choosing male is 7 over 10, 3 over 10. This is one class. Finish. Now the second class, the same student can answer in the second class. Like here, if one male came out, here you have to reduce because it reduced by 9. No, the male is not there. Okay, let's say 7 male. Inside here there's Ali. Ali is chosen as first male, so you have to reduce, left is 6 male only. Okay, so Ali cannot be the second person because how come, isn't it? Must be two different person. But here first class, let's say Ali answer, and the next day there's another class, Ali also can answer. Okay, so the two person can be same here. So no need to reduce. This is 7 over 10, this is 3 over 10, this is 7 over 10, this is 3 over 10. What is the probability that two students chosen are female? Here, go by branch, you will get 3 over 10, 3 over 10, that would be this is the answer for third one. Okay, exercise 1 here. Two dice are thrown together. Use a tree diagram to find the probability that one number is even, another number is odd. So dice, one die have 1, 2, 3, 4, 5, 6. Okay, so the probability of even number is, how many even number here? 1, 2 and 3. 3 over 6, 1 over 2. Probability of odd number, I put a D here, odd number 1, 2 and 3. Okay. Now first die, even, odd. Even, odd. One over two, 1 over 2. They say what is the probability that one number is even and the other is odd. So one is this is even, this is odd. One even, one odd. So you go by this branch. One odd, one even. Then you plus this, you will get 1 over 4, 2 over 4, which is 1 over 2. So the probability of even and odd is 1 over 4 plus 1 over 4, 1/2. That's the answer. Now exercise 2 here. Jack wake up late on average 3 days in 5. Wake up late. Late, not late. If Jack wake up late, the probability is late for school. Late for school, not late for school. Late for school, not late for school. On what percent of days does Jack get to school on time? So not late, school on time means we have to find this one. How much is here? How much is here? Not not late. Okay, go to school on time, not late. Wake up late on average 3 days in every 5. 3 days, 3 over 5, that would be 0.6. Right here, 0.6. Here 0.4. If Jack wake up late, the probability is late for school is 9 of this is 0.9. So here 0.1. If Jack does not wake up late, not no late, the probability is late for school is 0.3, 0.7. So information is done here. What we want just now, school on time. How much is this one? Go by branch. 0.6 multiply 0.1, you get 0.06. Go by branch. 0.4, 0.7, 0.28, you plus, and you will get, yeah, just plus here, I put it here, probability school on time. .34. So exercise 3 and exercise 4, 5, 4 later I'll give you the answer. You guys can try, and I also will do share the video if I have. Okay. Now we are moving to the last part, Bayes' theorem. Okay. For Bayes' theorem, before go to Bayes' theorem, I would like to show the tree diagram here. Here, if you notice, we found the probability of single probability, or single probability. I call this as a kind of marginal probability, a basic probability. Okay, we know probability of R, we know probability of R, not R, we know probability of umbrella, no umbrella, we know all the joint probability. This is all marginal probability, the single probability, this is joint, and we know also conditional probability like this. Okay, you are, you not you are, you not are, not you not are. Okay, all these things. Okay, we know this one, we know this, and also blah blah blah. There's another, you are. Okay, all this kind of probability we know, but we don't know, we from this information, do we know this one, the one switch, are you, that is also a probability that we can find, isn't it? We have u, not u, r, but can we find r, not u, switch the place. To find this type of probability, we are learning now Bayes. Okay, don't want to make it too complicated, but this is the main aim. How to, with this information, how we going to find this probability, the one we switch. Okay, all right. So I'm going back here. Bayes here. Before I go on, I need to get some information from here. I'm going to write here. There is some part here you have to fill up. I didn't show you here, but later, as I mentioned in the class, I will share Google Drive. In the Google Drive, there will be a folder for each chapter. So today we will finish chapter 1. Okay, we are going to finish chapter 1. In that folder, you can find all the materials for chapter 1. All you need to do is you have to practice yourself, the tutorial and everything. Okay, we will go through in the class also, don't worry, but you practice yourself before coming to the tutorial next week class. Of course, next week some holiday, but after that. So this one you have to fill up certain things. I will share also the complete slide with all this information. You can see that also. Right now, before we go for Bayes theorem, we have to refer to this example here. In a certain assembly plant, 3 machines B1, B2, B3 make 30%, 45%, 25% respectively of the product. So probability of machine B producing a product is 0.3. B1, B2 is 0.45. B3 is 0.25. It is known from past experience that 2%, 3%, 2% of the product made by each machine respectively are defective. So given that a product is done by B1, what is the probability of it defective? 0.02. This one will be 0.02. Okay, 2, 3 and 2. So these are the information we get from the. What is the question here? Question here is, now if a finished product is selected at random, what is the probability that it is defective? Basically they are asking PD, the single probability or marginal probability, PD. Okay, so as I mentioned in the class earlier, for us to find the PD, you can see here also. If I have mentioned this in the class, but I can repeat here. If I want U, what I take all the intersection with U. Okay, R is intersect with U, and R not R intersect with U. If there's something else intersect with U, I will take that also, and I plus this. Then I get U. That's how I get this one. Okay, so basically what we are doing, for me to find the defective, I will take all the intersection with D. Intersect with B1, isn't it? And then any other intersection, we can find B2. Any other intersection? B3. So if we manage to find this one and this one and plus, we will get this one. So let us find this one first. Let me find I want to find this one. Okay, how to find this one? Let me show one. It comes from the information here, the conditional information of done in B1 defective. The formula for conditional probability is like this. Now what is this one? Given here 0.02. This one we don't know, we're going to find this. What is probability of B1 here? 0.3. Multiply, cross multiply basically. There's a 1 here, cross multiply, but the 1 no need to worry about that. So basically what you get, if you multiply, you will get 0.06. So you get this one. You manage to find this one. Same method. We can also find this one. From where we can find? From here. B2 is 0.45. You cross multiply, and you will get 0. And the other one, zero point 0.02, B3 is 0.25, cross multiply, So you managed to get all these three. So for you to find the probability of defective, what you do, you take 0.006 plus 0.0135 plus 0.005. You get this one. So the answer for the first part, what is the probability that it is defective? This is the answer. This is not Bayes yet. This is not Bayes theorem yet. Okay, we just find what is the defective. Okay, now this is the second part, is the Bayes thing. If a product were chosen randomly and found to be defective, okay, what they are asking, if a product is defective, what is the probability that it is made by B3? You see, we have this information. We don't have this information. B3D we don't have, but we have DB3. Probability of B3, given B3, what is defective? We have this one. So Bayes is okay, we have this one. So from this information, how to get this one? That is where the Bayes formula or Bayes theorem applies. It is the formula I have given here. This is the formula. Okay, you can see the formula. Next class I will explain. You do the exercises first. The main idea is for you to know how to use how to get the answer. Okay, main idea is for you to understand. Okay, later once you understand, I will explain where the formula comes into the picture. Okay, now the main idea is, I hope you guys understand, given is this one, they will ask you to find the other one, switch it, this one, how to find this. That is where the Bayes formula comes into the picture. Maybe you cannot see the formula yet. Next time, okay, next class I will explain. I want you to understand and try to do the exercise first. So how to do this, what we want, this one, we have to find this one. So if I use the formula, I will get this one. But as I mentioned earlier, isn't that this one is equal to D intersect B? Okay, I have mentioned this earlier. D and B3, the probability of D and B3 and the probability of B3 and D is the same. We can switch, no problem. It's the same. So we found this already. Where we found this one? You see, we found this already. So you can write here. And then did we find this one? PD? Yes, here. That also we found already. We can put it here. And then if you compute, you will get 10/49. You can leave the answer like this in fraction. Decimal also can, fraction also can. I leave it as decimal, fraction. So the probability of it's become defective what is the probability? It's coming from the plant 3. So this is the answer. This is what the Bayes theorem teaches us. Okay, from any situation you know this information and you know the other information. How to find the other way around? How to find the other way around? This is where the Bayes formula comes in. Actually, we are using the Bayes formula here. If possible, you go through first this formula. Okay, we are using this formula. This is a formula. We are go through this one formula. Okay, this formula here we are going through from here to here. I mean from here to here. Okay, but if you cannot understand, leave it first. Try to understand this my working here, the working I teach you here. All right. So with that we will stop here. Okay, the rest of the exercises I will send to you. You can see, and I will also send you some video recording on this one, the one left. We went through one example. Okay, one example here. We went through this example. So the rest of the example and exercises I'll try to share in the Google Drive. Okay, also I will share all the tutorials. So next week we can continue little bit tutorial and we can move on to the next chapter, all these things. Alright, so that's all for today. I'll see you guys on next week. Next week is a holiday until 24, I guess. 23 or 24? Yeah, 24. So happy holiday and Selamat Hari Raya Aidilfitri for the Muslim. Okay, take care then.